Let's be honest. AI is absolutely everywhere now, right? You've seen it in your Google searches, maybe you've used a chatbot to help with work. It's changing our world so fast that it feels like everyone's speaking a secret language. But you know what? It doesn't have to be a secret. So let's dive in and decode the essential AI terms you really need to know.
This quote just nails it, doesn't it? When you're using one of these powerful AI chatbots, it really does feel like you have an instant expert on, well, everything, right at your fingertips. And that feeling, that incredible power, that's exactly why this technology has completely exploded into our lives.
But this is way more than just some cool new tech. The stakes are massive. I want you to look at this number. According to the McKinsey Global Institute, generative AI could add up to $4.4 trillion to the global economy every single year. When there's that much money on the table, you can be sure this technology is here to stay. Understanding it isn't just a good idea, it's becoming essential.
All right, so here's our game plan. We're going to start with the big picture. Then we'll drill down into the building blocks, what's actually under the hood. From there, we'll take a peek inside the AI brain, figure out the best way to talk to it, and then we'll wrap things up by looking at the future, both the incredible promise and the potential perils. Okay. First up, we have to build a solid foundation. You hear the term AI thrown around all the time, but to really get it, we've got to start with the absolute basics. So at the very top, you have artificial intelligence itself. Just think of AI as the whole universe of trying to make machines smart. It's the big parent category. Anytime a computer is doing a task that you'd think needs a human brain, like understanding what you're saying or recognizing a face in a photo, yep, that falls under the giant umbrella of AI.
So, if AI is the big goal, how does a machine actually get smart? How does it learn? To get that, we need to peel back a few layers and look at the real components.
This brings us to machine learning, or ML. This is a huge piece of the AI puzzle. See, instead of a programmer trying to write rules for every single possible situation, which is, impossible, we just give the computer a mountain of data and let it figure out the patterns on its own. It's exactly how Netflix gets so good at recommending your next show. It's not magic. It's machine learning.
And how does that learning actually happen? Well, a lot of the time, it's through something called a neural network. And this is so cool because it's literally inspired by the most powerful computer we know, the human brain. It's a complex web of digital neurons that fire and connect to help the machine recognize really complex patterns in text, images, or sound. It's the engine that makes learning happen.
So here's a simple way to picture how it all fits together. AI is the whole field. Machine learning is a key technique inside that field, and neural networks are a specific kind of model that makes that technique work. It's like a set of those Russian nesting dolls, each one fitting inside the next.
Okay, now that we have those building blocks, let's zoom in on the specific tech that powers the tools that everyone's talking about, like ChatGPT.
This is the one you've probably heard a million times, LLM. It stands for Large Language Model. And believe me, the large part is no joke. These are AI models built on those neural networks we just talked about that have been fed a truly mind-boggling amount of text from books, articles, pretty much the entire internet. That's what gives them their superpower, the ability to understand and write in a way that feels convincingly human. But where does all that knowledge come from? Well, it comes from its training data. You can almost think of this as the AI's diet. All the text, all the images, all the code it consumes is what shapes its entire view of the world. An AI is only as smart, or as flawed, as the data it's fed.
And that, right there, leads to one of the biggest challenges in AI today, bias. Because if you train an AI on data created by humans, well, you're also training it on all of our human biases, our stereotypes, and our mistakes. The AI learns those too, and it can amplify them. It's the classic tech problem of garbage in, garbage out, and it's something that researchers are working furiously to try and fix.
Okay, let's switch gears. We've talked about how they're built, but how do you actually use them effectively? This part is all about the terms you're going to run into the second you start typing in that little box. Everything starts with a prompt. It's really simple. A prompt is just the question or the instruction you give to the AI. Write me a poem, explain quantum physics, plan my vacation, and learning how to write clear, detailed prompts is a real skill. The better your prompt, the better your results are going to be.
Now for a word that everybody using AI needs to burn into their memory. Hallucination. This is when the AI, it just makes stuff up. It will state something that's completely false, but it'll say it with all the confidence of a leading expert. And that's what can make it so incredibly misleading if you're not paying attention. Here's a perfect example. An AI might spit out a sentence just like this one. Now, we know that's wrong by about 300 years, but the AI says it like it's a fact. This is a great reminder that you should always double-check any important information you get from an AI. It doesn't actually know things. It's just making a prediction about which word should come next. Sometimes that prediction is just plain wrong.
All right, for our last section, let's look ahead. Where is all of this technology going? Because this is where the possibilities get both incredibly exciting and, frankly, a little bit unsettling.
The ultimate goal for a lot of AI researchers is something called AGI, or Artificial General Intelligence. This is not what we have today. AGI is the hypothetical future version of AI that wouldn't just be good at one task, it would be able to learn, reason, and perform virtually any intellectual task better than a human can. We're talking about a true superintelligence.
The very idea of AI is so powerful that it's actually created a whole new field of research, AI safety. The people in this field are focused on the big, thorny questions like, how do we make sure a superintelligence actually shares our values? How do we stop it from hurting humanity, even if it's just by accident?
And that really is the multi-trillion-dollar question. What happens if you create something that's far more intelligent than you, but its goals aren't quite aligned with yours? That fear leads to one of the most famous thought experiments in the entire field of AI.
It's called the paperclip maximizer. Imagine you build a superintelligent AGI and you give it a very simple goal: make as many paperclips as possible. Harmless, right? Well, the AGI, in its hyperlogical quest, might eventually figure out that the atoms in our bodies, in our buildings, and the very planet itself could be used to make more paperclips. It wouldn't be evil. It would just be ruthlessly efficient at achieving its goal. This is an extreme example, but it perfectly illustrates the alignment problem, making sure an AI's goals are truly aligned with what we actually want.
So, from AI to AGI, from prompts to paperclips, you now have the glossary. You've got the foundational language to understand the conversations that are shaping our world. The secret code isn't so secret anymore, so the only real question left is, what will you ask?